Guys, welcome back to the scientific method unit, and in this video we are gonna go through each of the steps of the scientific method. Specifically, there are 6 steps, and let's look at them one by one. I hope you guys remember the toast experiment from the last video, because I will be making a lot of examples using those. Sorry. But yeah. So let's look at step 1. Step 1 is identifying the problem. What would you like to know? Now, if you remember the toast example, my question was, how do I make the toast? Now, that is something that I want to know. So I've identified the problem already. So I can move on to the next step, which is research. You can conduct research by looking it up on the internet, talking to people, talking to experienced professionals like chefs in this case, looking for relevant material in the library, looking at cookbooks or recipe books. For this particular example, looking at scientific magazines, journals. These are all ways for you guys to do research. In the toast example, I would probably either talk to my mom about it because she makes excellent toast, or I would look it up on the internet, or look up a recipe. And once I have done my research, I would form a hypothesis, which is step 3. Forming a hypothesis is basically making an educated guess about what your question was or what your problem was from step 1. Now, the important thing about step 3 is that my guess should be testable. It should be measurable and should be based on prior research or life experience. For example, my educated guess was that toast needs to be heated or bread needs to be heated using either a toaster, or I could also pan fry it, right? These are my 2 options. So I'm making an educated guess that if I go ahead and buy a toaster and put my bread in the toaster and let it sit for a while, it will give me a toast. Right? That is me forming a hypothesis. Now, this is testable. This is measurable. I can actually do this in real life. And it is based on my research. But a bad example of a hypothesis would be if I'm saying, oh, if ghosts exist, then my bread will turn into a toast. There is no way I can actually measure this. There is no way I can test this. So that would be an example of a bad hypothesis or a bad guess. After I form my hypothesis, let's say it was to go ahead, buy a toaster and let it sit for 3 minutes and that would give me a toast, I would go ahead and actually design that experiment to test it. This is the part where I would actually go to the store, buy the toaster, come back, and experiment with the bread to create the toasts. And this is where you use observations to measure your data. Now, experiment includes different variables. We have an independent variable. Independent variable is the part of the experiment that you change to see how it would affect your dependent variable. And on your graph, it would be graphed on the x-axis, or the one that is horizontal. For example, something that you change, right? So on my toaster, I can try changing the amount of time that I let the bread sit. For example, if it will it give me a toast if I let it sit for 30 seconds versus 1 minute versus 3 minutes. Now the amount of time that I change is the independent variable, right? On the other hand, the dependent variable is the part of the experiment that changes in response to the independent variable, and it is graphed on the y-axis, which is the vertical one on the graph. Now, something that is changing because of the amount of time that I'm using the bread in the toaster is actually the bread. So the bread turning into the toast here is the dependent variable, right? Because that is something that is changing as a result of the time that is spent in the toaster. And the third thing that we have is the control variables. Now, these variables are held constant and used for comparing. These are, so most of the time what people would do is actually have a controlled experiments, right? And controlled experiments is the one where you only test one factor at a time. So for example, I could test how long do I need to put my bread in the toaster for it to become a toast, or I could test, does using a toaster for 1 minute give me a toast, or does pan frying in a pan for 1 minute give me a toast. So these are two different things which I can test. But in a controlled experiment, I only test either one of these. And control experiments also use a control group and one or more experimental groups to make comparisons between these groups and infer the results. So what this means is in the same test, you would basically have different groups. In the same experiment, you would have different groups. For example, in one method, what I would do is I would put my bread in the toaster, but I would not turn it on. And I would take another toaster and turn it on for, let's say, 3 minutes and see which one gives me the best results. Now, the one that I turned on is actually the experimental group, and the one that I did not turn on was the control group. I'm doing nothing to it. I'm not making any changes, and that was the control group. I hope that helps. And if you have any questions about that, again, please go ahead and ask me. Now, something that we need to know about experiments is that the larger our sample is, the more accurate our results are. And that is to make sure that we didn't get a particular result that we desired out of luck or by chance. So to avoid those, it's better to have a larger sample. And better to repeat the experiment multiple times to reduce for other errors that we might not have seen. And a sample is nothing but a group that matches the characteristics of a given population. And for example, let's take another example where I want to conduct an experiment with people who have brown eyes. Now, obviously, the population of people who have brown eyes is crazy. There are so many people in this world with brown eyes, and obviously I cannot run an experiment with all of them. So what I would do is pick a few people, maybe 10 or 20 people with that characteristic of brown eyes, and invite them to conduct the experiment with me. And those people who I selected is the sample. I hope that makes sense. And the results are more accurate if the sample is as big as it can be. And after we have done all the experiments, we infer the data. Inferring means concluding. We try to conclude some kind of result or some kind of information after we have looked at all the charts, after we have looked at all the observations, and results of the scientific study can be one of the two. It can also either be quantitative, which is the numbered data, and numbered data is normally recorded using charts, tables, or graphs. For example, if I wanted to record how many red cars pass by when I'm waiting for my school bus, now that is a numbered data. So that is a quantitative experiment or a quantitative result for my study. But on the other hand, it can be qualitative, which is non-numerical data and may rely on key features or characteristics. For example, what characteristic describes kindness? Now, these are things that cannot be numbered, so it would be qualitative if you're looking for something very specific. And after you have looked at all your results, you would reach your conclusion, which is step 6. This is basically the summary of your results, and you would either state whether you accept or reject your hypotheses. If your guess in step 3 was the same as your result, then you accept the hypotheses. If it was not the same, you go ahead and reject it. And then in the end of your experiment, you tell us about all the practical applications of your experiment. How can we use it in everyday life? And that is it. Here is a quick chart for you guys to use to understand this better. So first you would ask a question, do some research, construct a hypothesis, test an experiment, and see if the procedure is working. If it's working, you would go ahead and analyze data and draw conclusions. And if it aligns with your hypotheses, you would communicate the results with all of us. If it does not align with the hypotheses, you go all the way back up here and construct another hypothesis. You create a new educated guess that's testable or measurable. And on the other hand, if the procedure was not working, if your experiment was not working, you would go ahead back here, all the way here, and create a new experiment or design your experiment by making some tweaks to make sure it works properly. And that is all I have for you guys today. I hope you guys had a great time, and go ahead and ask me questions. I'm here for you guys, and I hope I will see you during the live Zoom sessions. I will see you guys later. Bye.